Hello, this is Subramani, and we are going to discuss about similarity, dissimilarity, um, the different types of distance calculations in this particular section. So, to start with, what is similarity and what is dissimilarity? So basically, like no similarity, as the name suggests, like it's grouping of similar or like objects that are alike, and dissimilarity is like similarly that are different in clusters, like no that are not alike. So for example, in a class where you have 5 students or 10 students, out of which like 7 8 students are at the age range of between 20, 21, and 22, whereas like we have 2 students who are at the age range of say 45 and 55. So those are outliers. So if you compare the 45, the student who is aged 45 and 55 are outliers, which means they are dissimilar compared to the major population that are similar alike, which are the remaining 80 percentage of the students who belong to the 20 to 22 uh, 20 to 22 age range. So how the similarity is calculated? It's nothing but it's a numerical measure of how alike two objects fall between. So how are you going to give a numerical value to it? Like no, we give a numerical value of 0 for no similarity and 1 for complete similarity. And similarly for dissimilarity, we give numerical measure of how different two objects fall between. So 0 is for no difference and 1 is for completely different. So the next the next one is similarity, dissimilarity for simple attributes. So there are different types of attribute type. One is nominal, ordinal, interval, or ratio. So for nominal, like which is a very straightforward one, which we earlier discussed, where the dissimilarity d becomes 0 if the two objects values, attribute values, are equal. Say for example, p and q being the attribute values for two data objects, and if p and q are equal, it gets 0, and it gets 1 if they are not equal. So that's how dissimilarity is calculated for nominal. Similarly for similarity, it gets calculated as 1 if p and q are equal, and 0 if p is not equal to q. So for the data attribute type ordinal, it's calculated by using the mod of p minus q divided by n minus 1, which is the number of values. Whereas the similarity for the attribute type ordinal is calculated basically s equal to 1 minus mod of p minus q divided by n minus 1. So rather, like no, we can also say s equals to um 1 minus dissimilarity, 1 minus d. So sorry for my handwriting. So the next one is interval or ratio, which is for dissimilarity, it is calculated based on the mod of p minus q, whereas the same for the same attribute type, the dissimilarity has different equations. One where it gets directly calculated as the negative d, which is negative dissimilarity, and it is also calculated as s equals to the similarity equal to 1 by 1 plus d, which is dissimilarity, or s equals to 1 minus d minus minimum of d, maximum of d minus minimum of d. So as you know, like no interval or ratio, these type of attributes have range of values in the data set. So um, so since these are range of values, like for example, like the minimum is 1 and then maximum is 10, so you calculate depending on that, like no, by putting the values here, um, to calculate the similarity. So the next one is the Euclidean distance. So What is an Euclidean distance? So Euclidean distance is the distance between 2 points in the Euclidean space is termed as Euclidean distance. The distance can be calculated using the formula below. So the formula is square root of summation k equals to 1 through n pk minus qk the whole square, where the n denotes the number of dimensions and pk and qk are respectively the kth attributes or data objects p and q. If and Another thing that we need to note is if scales of the attributes differ, standardization is also necessary. And let's get to see how we can actually calculate this, right? So for example, like now say I have p minus q. um, so I have like I have p1, p2, p3, p4. So the axis points are given. So for p1 0 comma 2 x and y 0 comma 2, p2 2 0, p3 3 1, and p4 5 1. So I have plotted them in the graph, and now like now what I want to do is I want to find the distance between p1 and p2, p2 and p3, and then p3 and p4. So if I want to calculate this distance, that's when like now I'll be using the formula for Euclidean distance. So the formula, so for example, so right now for an example, I'm going to calculate only p1 and p2. So for this p1 and p2, p1 is 0 comma 2 and p2 is 2 comma 0. So distance equals to square root of 0 minus, so this x-axis minus this x-axis, 0 minus 2 the whole square plus 2 minus 0 the whole square. So this is how it gets calculated. So with that being said, so the distance becomes square root of 8, and then it becomes 2.828. So similarly, you can calculate the distance between p2, p3, p3, p4, and then if you want to calculate like p1 to p3, you can calculate p1 to p4. So it's up to us, like how what from which point to which point you want to calculate. So that is how the Euclidean distance is calculated. And the next one is the Minkowski distance. The Minkowski distance, it's not like very different from the Euclidean, where this is a very generalized form of the Euclidean distance. So it can be calculated using, so if you look at the formula, like it is similar to the Euclidean distance, where distance equal to summation k equal 1 through n, the mod of pk minus qk, the whole power r, and then the whole power 1 by r. So if you just substitute with 2, because like we had two attributes here, like now if you substitute it by 2, then it becomes like summation, it becomes the Euclidean distance. So depending on how many attributes that we have, like this, so here like that parameter r determines like now the number of attributes that you have, not the attributes, like the number of points that you have. So that's how it is calculated. So here the r is a parameter and n is the number of dimensions, and pk and qk are respectively the kth attributes or data objects p and q, which we had already discussed in the Euclidean distance as well. So the next comes like the Mahalanobis distance. So this is the distance between two objects or points in multivariate space. So the Mahalanobis distance is calculated equals to p minus q summation pi minus 1, which is the reverse covariance of p minus q transpose. So how you calculate the covariance matrix of the input data x, like there is a formula for that, and then on top of it you have to calculate the inverse covariance matrix of these independent variables or independent data. So here like what is this p and q denotes? So here p represents the vector or the data set of the observation. So the data set that is under observation, that is what P is. And what is the Q? It is the mean value of independent variables, independent data. So for example, like if you have say you have 240, 360, 300, and 600. So this is what your data said, say for one of the item in the that is one of the customer who bought items like for $240, $360. So what is the mean? Like how you calculate is you just add all the numbers divided by the number of instances. So for example, for this one, 600 plus 600, 1200 plus 300 becomes 1500. So 1500 divided by number of items, 1 2 3 4, which becomes 375. So you calculate the mean, which is the Q here. So and then, as you know, this one is nothing but the inverse covariance matrix of the independent variables. And what I mean, where exactly Minkowski is majorly used? What exactly it does? It transforms the columns into uncorrelated variables. So that is very important. We need to make this uncorrelated variables. And the next one is it scales the columns to make their variance equals to 1. And what exactly we are trying to achieve is we calculate the Euclidean distance at the end. And where exactly it is being used? So it is most commonly used to find the multivariate outliers. So I may have, say for example, I have it is very common to find, say, 6 feet tall a tall man to be 200 pounds. You can find number of such people, whereas if trying to find a 4 feet tall man or a woman weighing the same 200 pounds is very hard. So such kind of multivariate scenarios can be easily found in Mahalanobis distance, and so those can be removed in order for us to make our calculations and predictions accurate. And thank you.